Good morning, this is teacher Leland. We're going to do geometry today, and we're going to discuss segment addition postulate. Now, the segment addition postulate describes segments are added to complete the entire whole segment. Now, we will have to study the definition of between points. So given 3 points A, B, C, so that B is in between A and C, that is only true when they are collinear, and the statement AB plus BC is equal to AC. That is only true if they are collinear. And we can show that using some diagram. Okay, let us consider the 3 points ABC. 3 points ABC, such that these points are collinear. Given 3 points ABC, and this must be collinear, meaning they belong to the same line. These 3 points are on the same line. Now, definition of between points, B is in between A and C if and only if distance AB plus distance BC is equal to distance AC. Okay. The picture of this is a segment such that you have the 3 points on the same line, the 3 points on the same line. Point A, point C, and B is in between A and C. Now the statement AB plus BC equals AC if and only if they are collinear. So that's the definition of between points. And we're going to use this addition postulate, segment addition postulate in our examples. So just remember this concept, and we're going to have our examples. Okay. All right, let's have the examples on the other screen. Let me just get the other screen. All right, this is the segment addition postulate. Okay, for the first number, you can see we have the segment DF, and there's a point E. It's supposed to be in between points D and F. Now, point E is not supposed to be, or not necessarily a midpoint. It can be anywhere between D and F. So the way to solve this is to come up with the segment addition postulate formula, and you can see from the drawing. So if you start with the given, you have their DE, the DE segment, that distance, plus the EF distance is equal to DF distance. Yeah. And you have the given for EF, that's already 6. And we're actually after the length DE. We're after DE. And DF is given, the total segment length is 11. Okay, let us see the particular equation so that we can actually come up with the answer. All right. And we're doing it over here. Okay, here's number 1. So if you have seen the segment, this is the equation that sets up the working equation for that particular problem. And you see we're after DE length there. And the equation is DE plus 6 equals 11. And so solving for DE, this will just be DE plus 6. We subtract 6 from both sides. and DE is equal to 5 there. And that must be the solution in finding that particular part of the segment, and we shall see the answer. All right, let's check it out. Okay, our answer is 5. Let's see if it's 5. There. Okay, it's correct. Let's have the next example. All right, here's the next example. Let me just put it in my paper. For the second example, we have the segment S, and then R, and then Q. Those are the 3 points. We're after the segment SR. And part of it is 8 units, and the total length is 19 units. Now let's have the solution on the paper. Okay, let's do it in the paper. Okay, so this is number 2. And you can see here the drawing, and we're after SR. So writing the equation for this one, we're going to have SR plus RQ. SR plus RQ must be the total SQ. There. Then we substitute the given. We have part of it, which is RQ, that's 8. So we have here SR, the unknown, plus 8 must be equal to SQ, which is the total 19. There. And so, simple in your equation, let's find the missing segment by way of subtraction. So SR plus 8 equal to 19. We place a little space there. So minus 8, and then SR must be equal to 19 minus 8. That gives us 11. So 11 must be the length for this part. That must be 11. And we'll be able to check that out on the other screen. So let us check the other screen. And our answer is 11. Let's find out. There, it's 11. Okay, the answer is 11. All right, let's do number 3. Okay, here's number 3. And we're going to copy the problem in the paper. And you can glance at the given problem on screen while I put the problem diagram in my paper. So you have here point C, point D in between, point E at the end. We have another 8 units there. That's the question mark CD. We're looking for CD. The total length is 18. There. The total length is 18. And so we're going to solve this in the paper. All right, let's check it out. So this will be over here. Let me just adjust it a little bit so that we can focus on the paper. All right. So here is the number 3, the third. We have C, D, E. Our equation for this segment will be CD plus the distance DE equal to the total CE. So working equation will be CD plus DE equals CE. There. And we use the given parts, values. CD is what we are looking for. DE is 8, CE is 18. And we can right away solve for CD by way of subtraction. CD plus 8 and 18. We put a little space there. We'll be subtracting 8. And I suppose you know how to solve this kind of equation already. So this will be CD is equal to 10. 18 minus 8 is 10. And our answer is supposed to be 10 units. And we will find out by verification in the other screen. Must be this part. And what is the answer for number 3? 10. Okay, so that means we're correct. We're doing number 4. All right, here is number 4. Okay, for number 4, let's copy the given problem. We have the segment. We have 4 points. We have 4 points here, and we have N, M, L, and K. And ML is 1 unit, and then MK looks like 9. There. MK looks like 9. ML is 1, and we have NL 4. There. NL, which is 4. Now we're asked to get NK. NK is the total from point N to the end point, point K. Okay, so we're looking for the total distance of the segment. So the way to get the total distance is to know all the missing blanks. And the first thing we will do is find NM. NM, okay? All right, so let's do this in the paper. Let's do this part in the paper. All right, let's do that over here. All right, let me adjust the paper so that we can see it clearly. Okay, and put it slightly above. All right, so the way to do this is to solve for NM first, and then once we find that missing length, we'll just add all of this and we will get the total. So take note, if only we know NM, we can add to MK. And we have the NK. We're looking for NK here. NK. The distance NK from endpoint to endpoint. If only we know NM, then we will just add 9, and that's it. Okay. Now, to get the value of NM, you can see the distance here. From N to L, that's 4. Okay, that's 4. So that means we can solve for NM. NM plus ML is NL. There. And we have 2 of these numbers. The NM is unknown. The ML is 1 unit. The NL is given 4. So NM has got to be 3. Okay. So by way of subtraction, we have NM plus 1 minus 1 is equal to 4 minus 1. And we have something like NM is equal to 3. There. So NM is 3. And we can now solve for the required. Okay. And this is how to do it. All right. We can now set up the equation to solve for NK. Okay. All right. Here's how to do it. NM, which is already computed, NM plus MK. MK. All right. Is equal to NK. There. And we have NM, we already know that, that's 3. And plus MK, that's given, that's 9. And NK can now be computed. And this must be about 12. It's equal to NK. NK is equal to 12. And we shall write it this way. NK equals 12 units. Yeah. So our answer is 12. We'll be able to verify that in the other screen. We shall be able to see that over here. There. And the answer must be 12. There. Okay, it's 12. All right, next problem. We shall see number 5. Okay, this is number 5. How many problems do we have? Number 5, number 6, number 7, number 8, number 9, and number 10. Okay, we're doing number 5. Okay, here's number 5. Okay, let's copy the problem for number 5. We have to find UV, find the length indicated, find UV. So we're looking for UV in this particular segment, and we have 4 points. Okay, we have point S, point T, point U, and point V. And this is 12, this is 6, and the total is 27, okay, from S to V. That's 27 there. Okay, I have copied the problem. We'll do it next. All right, so let's do that in the paper. Okay, let me do a little adjustment. All right. Okay. All right. Here is number 5. Okay. Put a division there. All right. So here's number 5. You have their UV. That's the unknown, and that is that part there. Okay. That is that part. Now ST segment is given. That's 6. TU is given. That's 12. And the total S to V, and that's given 27. Okay, we shall now set up our equation. Now this is ST, okay, these are collinear points. These 4 points are on the same line, so they're collinear. So ST plus TU plus UV must be equal to the total SV. And so we will just set up the equation. ST plus TU plus UV must be equal to the total SV. This is the segment addition postulate. All right, and we're going to substitute the given. All right, we shall substitute the given. We have here 6. We add TU, which is given 12, and plus the unknown UV distance is equal to SV, which is 27. So we can easily solve this. 6 plus 12 is 18 plus UV equals 27 there. And then by subtraction, we shall subtract 18 from both sides. Okay, we shall subtract 18 from both sides to get the final answer. So we will just subtract here, minus 18 and minus 18 there. And we shall have the left side of the equation UV that is equal to the difference. This must be about 9 there. 27 minus 18, that must be 9. And our required answer is UV equal to 9. And we shall find out the answer on the other side. And we shall get that screen. And we shall remember our answer. It's 9. Is it 9? Yes. Okay. All right. So that will be it for number 5. Let us now continue with number 6. Here's number 6. Okay. We shall be able to get Km, the required, all right, if we know KL. Okay, you can see the segment there. If only you know KL, you will add the 7 and you have the total Km, okay, that part of the segment, Km. So you have to get KL first. And the way to do that is to get the difference between the 16 and the 8, okay, to get the distance between 16 and 8. So KL must be about 8. And so we can solve this orally. If KL is 8, we add the 7. 8 plus 7. 8 plus 7 must be 15. So the answer here must be 15. Okay? There. And that's how to do the solution orally, all right? And without any paper solution, you can actually see it from the drawing. All right, so let's continue with the next. All right, here is something different. This time it involves X. So before you can find any unknown part, you will have to solve for X here. Once you find X, you use that particular number, numerical value of X, substitute in the given expression. In this case, you're after JK, and you can see that 2x plus 32. Once you find your x, you substitute it there, and you'll be able to get the answer. All right, let's do number 7 using a paper solution. Shall be able to do it over here. All right, let's copy the problem first. This is number 7. We're looking for the length JK. We're after the length JK, and the drawing looks like this. We have point J, we have the K over there, and we have the L. This is 4, this is 2x plus 32. I'm putting it in the paper so it will be clearer. And the entire length is expressed x plus 24 there. So we will still use the segment addition postulate concept, and we shall see the written solution over here. Okay. All right, so we're after JK, actually, JK, and that will be this part from here up to there. Okay. All right, the moment we have the value x, numerical value of x, we can use it here. And then find the value of this expression, and that's the answer. Okay, so we will begin our solution, of course, by using the segment addition postulate. And that is JK plus KL. JK plus KL equals the total JL there. JK plus KL is equal to JL. Now we will be substituting the expressions. All right, this is 2x plus 32. 2x plus 32 for JK. There. Okay, let me adjust the screen. All right, let me adjust the screen. Okay, 2x plus 32, that's for JK. Now for KL, that means plus KL plus 4. KL is 4. And then equals JL, which is expressed as x plus 24. X plus 24. So this is now x plus 24 there. Okay, so what we need to do is find x in this equation, after which we can go back to JK. Okay, we can go back to JK. All right, so let us solve the equation first. This will be by way of subtraction and combining like terms. This is 2x. Let's combine like terms first. So this will be plus 36. 32 plus 4 is 36. And we have here x plus 24. All right. So let us subtract x from both sides. Subtracting x and subtracting x. That makes 0 here. And then it will just be 24. And this will be 2x minus 1x. That simply gives us x. And the 36. There. After which we subtract 36. And this is a negative 12. It's a negative 12, okay? That's 24 minus 36. So that's a negative 12 for x. Now we're going to solve for JK, all right? So here is JK. JK is expressed 2x plus 32. And we're going to substitute our negative 12 in here. So we have JK is equal to 2 times negative 12 plus 32. And that will become negative 24 plus 32. Now, negative 24 plus 32 is the same as 32 minus 24. And that must be about positive 8. There. And so the answer is 8 for JK. Okay. All right. This part here is 8. That's our answer. And we shall verify if it's 8 on the other side. Our problem set master answer over here. Okay, we're doing number 7. Is it 8? Yes. Okay, so that's the answer for number 7. Let's do now number 8. Okay, here's number 8 example. All right, here's number 8 example. Let's copy the problem first. We have here UW is the unknown. This is the required. Okay, we're after UW. It looks like that's the entire segment, UW. So from the drawing, you'll be able to draw the diagram first. U, and then V, and then the endpoint is W. UV is given 10 units, VW expressed x minus 1. The total is also expressed 2x minus 2. So this is 2x minus 2. Now let's do that in the paper. All right. So let's check that out in the paper. There. Okay. So let's adjust our paper a little bit over there. Okay. We're after UW. Okay. UW. All right. So we just remember that, and then let's set up our equation from the diagram. By segment addition postulate, this must be UV plus VW must be the total UW. There. That must be UW. And then direct substitution, this will be 10. VW is x minus 1. UW is 2x minus 2. There. Combining like terms, we can have that 10 minus 1, okay, or 10 and negative 1, that gives 9. So we will have x plus 9 here. There. Equal to 2x minus 2. Subtracting x from both sides, subtracting x, this must give us 0 here, and left side is just 9. The right side becomes 2x minus 1x, which is just 1x, or simply x, and we still have the minus 2 over there. So one more addition, we will just add 2 to both sides. We will add 2. So plus 2, plus 2. This is 0, and we will have x on the right side, and this will be 11. And the value of x is 11. There. And so we can now use 11 to solve for our UW. Okay? Our UW is supposed to be from this point up to this point. And that is given by the expression 2x minus 2. So we can equate our UW to the expression 2x minus 2. And so we can substitute now the 11. We can now use this value 11 and put it there. So this is just 2 times 11 minus 2, which is 22 minus 2, giving us 20 units for UW. And the answer is 20 for the unknown, the required unknown UW. This must be 20. Okay? And we will verify that in the problem set 20 is our answer, 20. Okay. Is it 20? Yes. Okay. So our answer is 20. Let's proceed to number 9. Okay, we'll do that in the other side. Okay, let's do number 9 here. Let me copy the problem first. Number 9 is find GH. So this is the known, and our diagram has the points FGH, FGH, the 3 points on this line segment. The FG is stated 3x minus 2. The GH is stated -7 plus 2x. And FH is the total, and it looks like 11. There. It looks like 11 there. So find GH. We're looking for this tiny segment at the end, GH. Okay, we're looking for the tiny segment at the end. So let's do this in the paper, and let's find out the solution. All right, let's get that portion. Okay. All right, here is the number 9. Okay, and I copied the diagram, and you can see the same diagram as the printed matter over there. All right, by the segment addition postulate, this must be segment FG plus segment GH must be equal to the total FH. There. Then we can substitute now. FG is 3x minus 2 plus GH, that's negative 7 plus 2x. And this must be equal to FH, which is 11. Yeah. Okay, so we continue finding x first. Let's find the x value. This will be by combining like terms. We have 3x and 2x. 3x plus the 2x is 5x. This is negative 2 plus negative 7. This must be negative 9. And this is equal to 11. By addition property, we add 9. And we add 9 to both sides of the equation. This cancels out to 0. And we will only have 5x at the left side of the equation. 11 plus 9 is 20. And then the next step is by division. Okay, we shall divide by the 5. We shall divide by the 5. And we shall get x equal to 4. Now we do not stop right here in the 4. We're not after the 4. We're after the length of GH. Okay, we're after GH. All right, so that must be this part here. Okay, and so GH. Okay, we can use this space here. GH is equal to negative 7 plus 2x. Now, we already know our x, and that is 4. Okay, this number 4 will be used right here. This is 4 now. All right, so this means 2 times 4 plus the negative 7, that is GH. There. And so this will continue, negative 7 plus 2 times 4, that's 8. And GH is just 1. That's the value of GH. That is the required segment. GH equals 1, and we shall find out the answer going back to the screen. Our answer is 1. There, it's correct. Now let's have the last number. Last number, okay. So we're doing number 10. This is our last example for the discussion. I hope this helps you in your ingenuity. So we're looking for PR there. And we have the segment P, Q, and this is R. And this is X minus 4, and this is 12. And the entire length, PR, is expressed 2x minus 4. Yeah. So we have PQ, that's x minus 4. QR, given already, that's 12. We're after the PR, the entire segment length. So we shall do this in the paper. Okay. Anyway, you can always repeat the video if you want to scrutinize the solution. Okay. All right. So this must be over here. This is now number 10. Okay. And we shall solve for the entire length PR. So let's set up the equation. By the segment addition postulate, we have PQ plus the segment QR must be the total PR. This is the working equation. And then we substitute x minus 4 in PQ plus QR in 12. And then PR is expressed 2x minus 4. There. Okay, so we will just solve for x. And once we have the value of x, we shall use this to find PR. Okay, and PR is this. Okay, we shall use the x here. And once we have that x, that becomes a number. We shall multiply it by 2, and then we subtract the 4, and we will have the required length. So we find x first. Okay, let's do this equation. We have a negative 4 and a 12. That combines to a positive 8. And we have the x. And the right side is the same, 2x minus 4. There. All right, so we are going to do a subtraction here. Subtract x first from both sides. Minus x and minus x. This zeros, and left side is 8. And we have 2x minus x. That's simply x. We still have that minus 4. There. So we add 4 to both sides to find the final value of x. Add 4. And this zeros out. You now have just x equal to 8 plus 4 here, which is 12. And we know our x. Okay, that must be 12. X is 12. And we shall use this value to find the required PR. Okay, the required PR. All right, let's get the expression for PR. PR is 2x minus 4. Okay, that's PR. So this is 2x minus 4. We shall now use our x equals 12. Okay, this 12 here, that's our x. So this is 2 times x means 2 times 12 minus the 4. And this looks like 24 minus 4. And PR looks like 20. Yeah. And let's see the answer. Is it 20? That should be over here. That's our answer for the last problem. Yes. Okay. So our answer is 20. All right. I hope you were able to learn from the examples. This will be for today's discussion in geometry A. All right. I hope you learn from this and use it in your ingenuity. Thank you for learning. Bye-bye.